So I think this whole thing is linked to previous. So what we try to do is to actually hit the target, which is getting the 0 in, right? So and that's the broad perspective on what we try to do. So as you can see, is using a plus b plus c. So I mean, we can kind of like write that down, that what we use is a plus b plus c to get our target value, which is the 0. So that's fundamentally what we try to do. At the in array, it was like given an unsorted array. So you can sort the in array into a sorted array. So that's what they actually do. The first thing that we see is that how you can actually manipulate the data is that, because in previous we actually learned that if you do like a says the b plus bc, you can actually refer it to using first and foremost the 2 pointer to actually count them. And the next one that we actually were using a lot, which the most intuitive one, was the brute force. So that way you BON square, you count like a bajillions of like the parents for every single number, what not have you. So that's the two ways that we can actually approach the problem. And so now I think that this problem is slightly more difficult. As you can see, it's called a three sum. So two sum we do know, which is this 2 pointer method, and it's also known as two sum lah. And the two sum does solve for b plus b, but then how do you then solve the a? So as we see, we do have used these two methods, and we can just simply use the brute force method to actually try to solve it. And then the strategy is then use a 2 pointer for this one to actually solve it. So that's how we actually gonna try approach the problem. And if we actually try to actually zoom in towards, so I'm gonna discuss actually another strategy that you can actually do, which is because you see that there's like a plus b plus c, right? So one can actually argue also that why you think so hard, like why not just brute force and brute force every single thing? I mean, you can do that, but I think what the bad side of this is that the time wastage will be sort of like n cubed, because each of the brute force takes n. So if you n times n times n, you n cube. It's like a bajillion of pattern times the bajillion of pattern, you then get this n cube. But for brute force, at least it then go to the shape of n squared, because brute force is n, 2 pointer is n, you n times n, you become n squared. So that's the deal with it. And I mean, for the video, they actually do suggest that that they recommended the stage 2 method, which is that they go through by every single pattern. So they discuss about like, okay, I put this A and I put this as B and this as C, and if you were to see this, and um, this and this, you actually do get the target value, right? So what we actually try to do here, it was like brute force inefficient, because you got to run a lot of like down pattern. Because if you were to say that you still want to find a second pattern, you still have to keep on running, right? You can't just stop. So what if you then put a B over here, and then you run the C over here? So I think that first and foremost, it's rather difficult to actually do it this way, because I mean you're running a lot of like pattern. So and we are talking about like 3 variables instead of like 2 variables. 2 variables, I feel a lot of like that is just very complicated in some sense. Just gonna run some demos into it. So maybe the B can be here now, and then we run throughout the whole C, and then the B slightly expand again, and all the C's. You see, we are wow, I just and I don't exactly know how sure it was it to actually triple brute force an item. What I've experienced so far was like the double brute force, which is only having 2 variables. So say for maybe say just a B plus C. I done the brute force before for this one, and I checked how to do it. But when you talk 3 variables, it's a different story in my opinion, and I just feel I lack knowledge in doing A plus B plus C for the brute force. Basically, stage 2 I'm very unfamiliar with. So but all I can say is that it's tedious. You run through a lot of pattern, and you run into an NQ. So having said that, we move on to stage 1. Yeah, and that yeah, sure, stage 2 we're kind of unclear a lot about a lot of things, but we move stage 1. Stage 1 is saying that okay, now I have this value. And one thing that they actually discussed a lot about was that they want to take care of like duplicates. So say if one of like so if this value I took was a value that is being taken, I don't want to see any of like this value to contain this one value, right? So that's something that we take note of in our computer. So that being said, this one we have A, and then from here we just do start to do like maybe say a 2 pointer, right? So we do 2 pointer here, and we slowly do combination for everything. That means, having said that, was that our A will brute force its way through all of this, while our 2 pointer will sort of adjust accordingly to where A is current at. So basically our A will run through every single one, and our 2 pointer will adjust based on where the A is. So if A is here, we're gonna count the 2 pointer for this whole thing. If A is here, we gonna do a 2 pointer from here all the way to here. And just one item before was that we did do a sorting from the in array. I mean, it's for the sake of 2 pointer. So if you watch previous for for 2 pointer, is that we sort every single value, so that in as such that if we take this 2 pointer in, right? So if we were to shift the right pointer here, it means that we are sort of decreasing value. When we want to increase value, we take the right left pointer as such. So it's necessary for us to do sorting in the in array, for us to conduct a 2 pointer after. So that's what happens. You have the first and foremost A here, and just very luckily that the first pattern is sort of get the answer already. I don't know, they coincidentally am able to actually get answer right down or not. And I don't, because of them maybe coincidentally having like the first element as the part of like the brute force A, right, to be here to straight away find your answer. I'm not sure if the A will be actually be conducting on the next few variables or not. That I'm not so sure, but my guess theory is that it does run. All these does run, but they didn't really show, so it's not confirmed. But from what I get, the main idea drive across was that to do with the A to be here, and then the 2 pointer for the rest of it, right? So and like what I said, it will take care of the duplicate. So if A is over here already, the next two elements I don't want to see a -3, so this one it will be auto remove, and then it will do 2 pointer for here. So you do the 2 pointer, eventually it does get this 1 and then the 2 and then the -3, and then you do get the result, right? So there you have. I think that I mean, when you compare stage 1 and stage 2, I believe that stage 1 is so much more efficient in terms of how it counts. And one thing to actually note that we need to actually consider the time taken to be able to do the sorting, but it doesn't affect the overall timing, but it's n log n to do sorting for the in array for both sides, for both stage 1 and stage 2. But overall, I think we just do for this stage 1 for us to actually for best way to actually do is yep, everything comes to an end.